Your homework solutions for question number 2 from 2019. Again, I want you to try your best first before you just copy the video. So, here we go. The velocity of a particle. What type is this? Velocity, acceleration, particles moving, when is it stopped, total distance, things like that. All right, so velocity of a particle p moving along the x-axis is given by a differentiable function there. And you see a table that's given. It says justify why there must be at least one time from 0.3 to 2.8 at which the derivative of the velocity, which is the acceleration, must equal 0 meters per hour. And so for this question, they're looking at the mean value theorem, that I rock equals A rock from there to there. So how could you take the derivative using two values like that, right? Is that we're going to go y2 minus y1. So there's question number 2. So this is 55 subtract negative 29, 2.8 subtract 1.7. Oh, I put in the wrong numbers. It wasn't going to equal 0. Sorry, it's 55 take away 55 and this and this. So obviously 55 take away 55, there it is 0. So what? They're looking for the mean value theorem. You can write those letters down. I think that states there must be at least one time. Differentiable and continuous. All right. There's part A. Part B. Part B might be easier at first because you get a better sense of what you're doing right away. A trapezoidal sum, using those to approximate that integration. So I want to integrate from 0 to 2.8. Write down what you're doing. A trapezoidal sum, all the widths are not the same. So we have to go by each trapezoid one at a time. So how do I do a trapezoid again? So first of all, we start with 1/2. And then the distance, the width, is 0.3. And then you add the two heights, 0 plus 55. I can do that. Plus, again, start with 1/2. A trapezoid, the distance here, 1.7 and 0.3, that's 1.4. You can use your calculator if you need to. And then add 55 and negative 29. Was that 24? Or 26? 26. Do it again. Between 2.8 and 1.7, that's 1.1. And then again, add negative 29 and 55, and again, I think that's 26. And then one more time, between 2.8, or end at 2.8, sorry. So we're ending there at 2.8, so no more. So those are my trapezoids. If you used a calculator, the answer would be 40.75, but this is unnecessary. Part C. A second particle, Q, moves along the x-axis so that the velocity from 0 to 4 is given by this equation. Find the time during the interval during which the velocity of Q is at least 60 meters per hour. Find the distance traveled by the particle during the interval when the velocity particle is at least 60 meters per hour. So we're going to take this equation and we're going to solve it. So it's 45, can't even read it, square root of t, cosine, look at that. Could they put an uglier equation in there, right? So I want to know when it's at least, so 60 or above. So this is what we're going to do. We're going to graph this from 0 to 4. We can do it. I got to turn it on first. Let's do it together, maybe. I already have something in here from the last question, so I'm going to erase that. And let's just start one at a time. Press tab. What am I going to type in? So I'm going to type in that equation. 45 times the square root of x times cosine, and it's 0.063 x squared. Make sure I type it in right. Now we're going to change the window in a moment. I'm going to press tab, and I'm just going to do the horizontal line of 60. I want to know when it's above that line. And now I'm going to change the window. So we're going to go to the graph, or the window, I'm sorry, and then the window settings. And so we're going from 0 to 4. And really, all I'm looking for is, so I'm going to make it like close to it. So like between 40 and 65, whatever, 70. I'm looking for when it's above 60. So I set up the window, and can you see the part that's above? I need to know what those values are, where they intersect. So I'm going to go Menu, Analyze, Intersection, number 4. And then press down and to the right. So I got 1.866. And then the other time, I need the other one too. Analyze, intersection. So to the left of it, press down, and then to the right of it, highlight over it. If you're having a hard time seeing it, which I am, grab it, press down, and then move it so you can actually see the numbers. All right, so it's 3.519. So the first question was, find the time interval between the velocity is at least. So the time interval is right there, between 1.866 and 3.519. And then it says find the distance traveled. That's an integration question. So we're going to integrate from 1.866 to 3.519. Everything is positive, so I don't got to worry about absolute value between there. And then I'm just going to type this in. So I don't have to write it again. So it's the velocity of q at t dt. So I'm going to integrate the velocity from there to there to see the distance traveled, or the area under the curve. So I'm going to use my calculator to do that. It's right there. So I'm going to press Menu, Analyze, and Area. That's going to be 8. And then the lower bound is 1.866, 1.866, and then press Enter. And then the upper bound is 3.519. Press Enter. And then that will give you the area. Now it expanded here. And I get 6.929, right? Is that what it is? For that area from there to there? What's happening? Why did the graph do that? That's not the right answer. So I want to figure out what happened. Okay, let's do it a different way. So let's go Menu, Calculus, Integrate. And we're going to use those numbers again. 1.866 to 3.519. And again, I'm integrating that velocity. We just said was F1 at x, so I don't need to retype it. It's in there in the calculator already. There it is. 106.109. Part D. At time t equals 0, particle Q is at position negative 90. Using the result from part B and the function of velocity of Q from part C, approximate the distance between particles P and Q at time 2.8. So, at 2.8, what do we know about particle P? So particle P is at 0 at 0. So, if I integrate from 0 to 2.8, we already did that, right? We did that in part B for the trapezoidal sum. So, what did I get for there? The position, right, is 40.75. So that's one position. So at 2.8, that's the position for one. And then for the second one, the starting value it gives you, so at time t equals 0, it's at position negative 90. So we start at negative 90, and then we're going from 0 to 2.8. We're using that velocity for Q, and then we're going to get an answer, and then subtract the 2. So, negative 90, we're going to integrate from 0 to 2.8. We have that, 2.8. We already have that equation in the calculator. And see, what's the position now after 2.8? And it's 45.937. And then subtract those two numbers. And what's the distance between them? 937. So I'm going to subtract 40.75 from it, and I get the answer 5.187. So set up what you did, and the distance between them is that. So this was given in part B. We solve this by integrating. What's the starting value? You integrate the velocity, figure out what that position is, subtract, and then get your answer. Mr. G Math over and out. I'm super proud of you for doing your work. Until next time.